We can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. We now know how our world ends our affinity with sci-fi movies, and perhaps the Bible would point toward the big bad apocalypse. But what if we tell you that the end of the universe is no different than its inception? The James Webb telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago, and in doing so, he gave us the most realistic starting point to imagine the end of the world. We can look to light that began its journey before there were galaxies, and that's the oldest light in the universe, which is, by the way, one of the pieces of evidence for people who don't believe in the Big Bang. The answer is, well, you can see it, we're heading towards Big Bang 2.0. Join us as we explore why the universe has stopped expanding and James Webb's terrifying discovery. The Big Bang Theory, if we're certain about anything in our knowledge of the universe and its history, it's the fact that our very epic of existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe, but we're not getting into the validity of these theories today. Mainly because the astronomical community has now readily accepted that our history in this universe starts with the Big Bang. And the ideas that succeed the Big Bang are also based on the same common point of the universe's birth. While the Big Bang is a common word in the theoretical knowledge of astronomy and space, we're hardly aware of the whys and the hows of the phenomenon unless you're a nerd who has spent hours watching some excellent visualization of the Big Bang. To be fair, the phenomenon was more than an explosion, so to speak. Simply put, the Big Bang finds its origin in a single point that was infinitely hot and dense, that inflated to extreme lengths. All of this was when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of minus 34 seconds old, that is, 100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or inflation. During this process, space expanded faster than the speed of light. So yeah, you wouldn't have even blinked when the universe grew 90 times in size almost instantaneously, from subatomic size to golf ball size. 1 second after the inflation, the universe began to cool, and that led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second our universe was full of every particle we've learned about in our chemistry class, willingly or otherwise. Protons, neutrons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively it looks like it, but our understanding of the universe's inception is highly theoretical. We've come a long way since the first moon landing, and since then, our technological advancement has grown exponentially. Back when scientists were studying the Big Bang only based on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. There have been some big breakthroughs in our pursuit to study the universe and explore space, yet even then, our existing technology is pretty limited. You see, we can't recreate the Big Bang or peer back at the event itself. Our biggest piece of evidence comes from the cosmic microwave background, which has allowed scientists to observe the echo of the Big Bang. While this mechanism is groundbreaking in the study of the universe, it's also theoretically limited. The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from the expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disproven as well. Yep, we're pretty sure about the Big Bang as a concept and how it was monumental in creating our universe, but there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that at this point in time, it's not easy to disprove the theory altogether. At the universe's inception, the rate of expansion had only increased from its earlier data points. For the most part, this unexpected theory was hard to explain. Of course, gravity couldn't cause the faster acceleration. If anything, gravity should have fought valiantly to deaccelerate the rate of the universe's expansion. But by all accounts, gravity was rendered powerless. In fact, to this day, we don't know how or why the universe was expanding to astronomical degrees. As per theoretical knowledge, the expansion should have slowed down unless there was an anti-gravitational force in the universe effectively overpowering gravity. Until the recent discovery of the James Webb Space Telescope, scientists were mostly of the opinion that our universe is a huge battlefield. Here's why: after Hubble's discovery, the scientific world was in a crisis. Agencies like NASA wanted quick explanations for the unprecedented cosmic acceleration. Our first guess was that perhaps Einstein's theory of gravity wasn't as accurate as we thought. According to the theory, we had started to recognize gravity as a distortion of time and space caused by mass and energy. In theory, gravity wasn't just a force it could wrap around mass to push or pull it. So if this theory stood correct, the universe shouldn't have been expanding at accelerated rates. Another possible explanation was some energy fluid that hastened the expansion. Many theories came and went, but nothing really stood its ground. Eventually, the possibility of falsifying Einstein also faded away. Today, the only answer to Hubble's astounding discovery can be summarized in two words: dark energy. Now you know why this throwaway word in science is so important, but you'd be surprised to know that we don't know anything about this force, none at all. The only thing we do know is that it makes up the majority of our universe. It's almost frightening, but normal matter constitutes just 5% of the universe, the rest is dark matter and dark energy. This also proves Einstein's notorious cosmological constant. The way Albert Einstein explained empty space was always as an entity with its own force, and as the universe expands, this force wouldn't change or get diluted in the slightest. So, how is this related to what the James Webb Telescope shows us? Why has our universe stopped expanding in the presence of dark energy? Scientists are still grappling with this bizarre discovery. If we look at the duel between gravity and dark energy, we might find an answer. The cosmological constant is the enigmatic force in space that can be substituted for dark energy. The scientific theory suggests that gravity and dark energy are always in a battle, and it's about which one overpowers the other. Before the universe stopped expanding, dark energy seemed to be giving gravity a run for its money, accelerating the universe's expansion. Now, this phenomenon has completely halted. Given our limited understanding of space properties and dark matter, scientists have no clear trajectory to explain this disruption. While NASA was already expecting anti-dark energy to emerge, this particular twist in physics wasn't anticipated in our current epoch. As Brian Cox would put it, the halt in the universe's expansion is entirely new physics. One simple and logical explanation could be that gravity is finally overpowering dark energy to stop the expansion. If the universe had a trajectory, it would have contracted to a significant degree before the expansion stopped. Or perhaps gravity began canceling out dark energy unexpectedly. In either case, substantial observational and theoretical proof is required to justify whether gravity is changing its properties, a daunting task, because so far gravity has never changed. Since the universe's inception, gravity has remained constant, and we lack evidence suggesting a shift in how it interacts with the universe. This is terrifying. The Big Crunch theory suggests that gravity might one day overpower dark energy, causing the universe to collapse in on itself. Brian Cox, in his 2011 book Wonders of the Universe and the TV series of the same name, touched on the possibility of the universe's eventual collapse. According to Cox, if our universe has stopped expanding, this could mark the beginning of the end, leading to the universe collapsing back into a singularity, just as it began with the Big Bang. Cox's theory suggests that the universe's contraction would take billions of years, but recent discoveries hint that we could be much closer to the Big Crunch than previously thought. Princeton University scientists have revealed that the universe's expansion is slowing at exponential rates, meaning that the Big Crunch could occur within a cosmic time frame much shorter than previously imagined, perhaps even in the geological timescale of millions rather than billions of years. The idea that the universe could collapse within millions of years, in a scenario similar to the extinction of the dinosaurs 65 million years ago, is both fascinating and frightening. While this may seem far off in human terms, it is a mere blink of an eye on the cosmic scale. As of now, the James Webb Space Telescope remains our best hope for gathering more data about these cosmic transformations. The end of the universe, whether through the Big Crunch or other cosmic events, is a topic of serious scientific inquiry. While the Big Freeze theory once suggested that the universe would slowly cool down and die as it expanded, the halt in expansion has pushed the Big Crunch theory back into the spotlight.
But there are some
Ultimately, this means that rather than freezing,
and as shocking as it
the universe could collapse in on itself in a catastrophic cosmic event. Whether it's the Big Freeze or the Big Crunch, Humanity's
same
place in
time,
the universe's
some of our
fate is
data
uncertain.
is also highly conclusive about the Big Bang.
0.30457967991.
Let's just say that at